So you want to know what are the exponents. Let's look at this here. What is this small number 3 doing to the top right of the big number 5? Well, the big number 5 is called the base number, and this small number 3 here, that's the exponent. And in this video I'm going to show you exactly what are the exponents and how do we use them. Think back about multiplication. You remember that 5 times 3 equals 15. But you can also write it as 5 plus 5 plus 5. When I'm saying 5 times 3, what I'm saying is adding 5 to itself a total of 3 times. 5 times 5 times 5. So how can I do this, but instead of adding each time, doing this? Multiplication. How can I express 5 times 5 times 5? Well, the way we do that is using the exponents. In this case, 5 is the base number and 3 is the exponent. So what I'm going to do is take 5 and multiply by itself a total amount of times that equals the number of the exponents. So in this case it is 3, so it is 5 times 5 times 5. 5 multiplied by itself a total of 3 times, and that equals 125. Remember, the first 5 times 5 equals 25, and then I multiply 5 again, so it becomes 25 times 5, and that equals 125. This whole process of multiplying a number by itself using the exponent is called exponentiation. And the way we represent it, as I said before, the big number is the base number, the one that gets multiplied multiple times, and the exponent, which tells me how many times I'm going to multiply the base number by itself, is called the exponent. This is the same thing again. A is any base number, and I multiply A by itself n amount of times, and n equals the value of the exponent. Now this works if the exponent is positive and it's an integer. Later we will see what happens when the exponent is not positive or is not an integer. But if the n, the exponent, is positive and it's an integer, you just multiply the base number n amount of times, and remember, n equals the number of the exponent. You can read, instead of saying that the base number is a and the exponent is n, you can read it as a raised to the nth power. Let me show you with a number. Here the base number is 5, the exponent is 4. You can read that as 5 raised to the 4th power, or 5 to the 4th. Sometimes people read it just like that, 5 to the 4th, or 5 raised to the 4th power. Now there are some quite famous exponents because they have some special properties. For example, when the exponent equals 0, the result is always 1. Doesn't matter which number you have or any variable, as long as the exponent is 0, that becomes 1. Another exponent with a special property is the exponent 1. Any number with the exponent 1 stays the same. Just like with multiplication, when you multiply something by 1, it equals itself. 5 times 1 is 5. You don't even have to write 5 times 1. You just write 5 because both are equal. So here we see that a times 1 equals a. That's why you're probably never gonna see any number raised to the power of 1. The same way you're never gonna see any number multiplied by 1, because they just equal that number. Now a, or any base number raised to the power of 2, when the exponent equals 2, instead of saying, like I just said, 8 raised to the power of 2, what is commonly used is saying a square. When you say any number square, you're saying multiplying that number by itself. For example, some very common squares are 2 squared, which is 2 times 2, which equals 4, or 6 squared, which is 36, 6 times 6, or 15 squared, which is 15 times 15, which equals 225. So remember, exponent equals 2, you say that number, whatever number, squared. When the exponent equals 3, we commonly call that, instead of a to the power of 3, we call that a cubed. And a cube, or any number cube, is the number multiplied by itself 3 times. For example, 2 cubed is 2 times 2 times 2, which equals 8. 3 cubed, 3 times 3 times 3, 27. And 10 cubed, 10 to the power of 3 is 10 times 10, which is 100, times 10 again, which is 1000. So those are the exponents. Remember, the base number is the big number, and the small number to the top right is the exponent. If the exponent is a positive number and is an integer, what we use the exponent for is to multiply the base number by itself an n amount of times. The n amount means the value of the exponent. For example, here, 7 to the power of 4, 7 to the 4th power, means that I'm gonna multiply 7 by himself 4 times. Means 7 times 7 times 7 times 7 again. A total amount of 4 times multiplying the 7 by itself.